name is Osvaldo Fernandez, and today we will be taking you through our gearbox design for Mechanical Design 2 project. So the problem description for our project was our gearbox was supposed to transmit a horsepower 3.5. We're going to have a 16:1 ratio between the input speed and the output speed. We have a right angle shaft orientation. Rotations of the shaft have to be opposite of each other. Our gearbox was designed to withstand moderate shocks, high humidity environments, and 68-degree temperatures, plus or minus 50 degrees. Our target applications are food processing, situations such as cheese slicers, conveyor belts, meat processing, things of that nature. Boston Gear provides a readily available gearbox that has the same horsepower rating, same output, same shaft orientations, although their RPMs are slightly slower, and their cost is $1,716. Now, Alex would take you into our design process.
Good afternoon, my name is Alejandro Diaz, and I'm going to be taking you through some of our prototypes. For this project we had 3 different prototypes, and I'll take you through our actual designs and why we ended up having 3 prototypes. So for our first one, we just did a basic setup. We downloaded these gears directly from Boston Gear. This accommodated our 16:1 ratio, and I just threw a quick box together. But when we finished doing this, we realized that we ended up looking at the Boston Gear catalog incorrectly, and our horsepower and torque ratings with our satisfied RPM for each gear through the reduction was not sufficient enough, and the AGMA of course didn't pass. So in our next prototype design, we beefed up the gears a little bit, made sure that we understood the catalog more clearly, and this is what we came up with. But actually, when comparing our Boston Gear catalog ratings to the AGMA process, our AGMA did not pass, which was a little bit confusing for us that Boston Gear said it would pass and AGMA wouldn't pass. So this led up to our third design, which would be real beefed up gears, keeping our 16:1 ratio always satisfied. Here we really overshot the Boston Gear catalog for their satisfications for horsepower and torque, and then shot up our safety factors for bending for each gear, but our wear ended up just passing. In all our gears, you'll see in our next slide, we'll look at the housing. For all our designs, we took into account a closed system to not have to introduce humidity. As we previously mentioned, our gearbox would be used in food processing, so we didn't want to contaminate our environment that it would be working in. We introduced some spindles with some basic bolt patterns so we could use it in different types of applications. I also combinated on some bolt holes and some drain plugs and different plugs, and I'll run through them now in our next slide, or in our other slide. Here we look at our cost estimate, broke down our bill of materials and predicted costs for what was actually given on the internet. Our total was about $1321.44, which compared to the Boston Gear one, it's about $400 cheaper. Next slide, what I was previously mentioning, some of the features that we did just for serviceability and maintenance, just in case something happens to our system. We accommodated for screws or nuts or open-ended bolts, some lubrication holes, some fillers, and since it'll be a closed system with oil in it, a breather valve. On the bottom, it has a drain on the bottom and on the side, depending on what application you use our gearbox for. Thank you.
Justin Cromartie. I'm going to go over why we chose the third prototype. As you see listed here, we have our rated torques, the minimum values we need for the gears to pass at each junction using this equation at the top, and we used a spur gear and bevel gear setup. As Alex said in our first iteration, the AGMA and the Boston Gear selections both failed. As you can see, the bending stress at the top was nowhere near the safety factor needed, as well as the spur gear wear. So in order to counteract this, we went back, tried to beef up the design, and the spur gear bending worked this time, but the AGMA did not work. So again, we went back in and beefed it up even more, making a 4:1 ratio. Next slide. On the third prototype, and as you can see, our bending factor safety passed very well, while our wear barely made the mark, so it worked correctly. And here we have our total characteristics of each junction. As you can see, we have 3 different junctures. As I said, spur gears and bevel gears earlier. Each listed safety factor for both bending and wear, as well as the wear and bending stresses at each point. Thank you.